All right, welcome back, everybody. This is the next question in the series of questions that we are trying to solve, or rather understand, with regards to the concept of circular motion. These questions have been obtained from the Cambridge publishers. The author is K.A. Sokos, and this is the 7th edition. In this specific question, the question is about representing all of the forces acting on a body which is moving in a circular path, and this body is moving at a constant speed, and it is moving in a horizontal circle. All right, so as a part of this question, it says that the string is attached to the ceiling. The string is tied to the ceiling. All right, so there you go, there is a string tied to the ceiling, and then it is further talking about uh, a circular path. So let us consider this to be a circular path here. I hope you are following the diagram. We have this same string here. There you go, that is the same string, and I have a body, a particle attached to the end of the string. So what do you think are all the forces acting on this particular particle? Needless to mention, there is going to be a gravitational force. There you go, that is our mg. And since the particle is hung onto a string, there is going to be a tension T as well. If we further try to understand this, well, the question is, whatever has been asked in the question, we were able to already represent that. But then going a step forward, since the body is moving in a circular path, there obviously should be a centripetal force. Now, centripetal force, we need to understand, is not a new force. The existing forces, or rather the sum of all the existing forces, will be playing the role of centripetal force. Isn't it clearly mentioned that this is moving in a horizontal circle? Therefore, am I allowed to say that this tension force here can be resolved into two components? One component will be along the vertical there, like that, and then there is another component which will go in the horizontal manner in this way. If I make an assumption that the string has been pulled out by an angle theta with respect to the vertical, if this angle is theta, the angle that I'm showing here will also be equal to theta. I hope you understood the reason behind that. Now, if this angle here is a theta, the component here, that can be written as, this component here can be written as t cos theta. There you go, this is t cos theta. And the other component here, that can be written as t sin theta. I understand that the vectors that have been drawn here are not to scale. So let me redraw the mg here. That force here will be equal to mg. Right. Now, if this force here is mg, since the bodies are moving in a horizontal circle, we can establish the fact that mg will be equal to t cos theta, indicating that the net force here will be t sin theta, and this will be playing the role of the centripetal force. And are we also further aware that the formula for centripetal force is equal to mv square upon r, which therefore goes on to say that t sin theta will be playing the role of centripetal force, therefore that will be equal to mv squared upon r. Now, depending on the question, we can extend this further. We can say that, hey, you know what, mg is equal to t cos theta, indicating that t is equal to mg upon cos theta. Now that we are having a T is equal to mg cos theta, that can be substituted here. We will end up getting, in place of T, I'm going to write mg upon cos theta into sine theta will come in as it is. This is your sine theta is equal to mv squared upon r. Here we can strike off mass and mass. Sine theta by cos theta is in fact tan theta. So we would end up having g times tan theta is equal to v squared upon r. Now all of this has not been asked of us in the question given. We are only extending this forward and trying to understand the more intricacies of this particular question. V squared upon r, we pretty well know that can be considered as a centripetal acceleration. Therefore, centripetal acceleration is then equal to g times tan theta. I hope all of you understood how to solve this question. We further need to understand, again going back to the free body diagram, centripetal force is not a force which is shown on the free body diagram. The existing forces or the sum of existing forces will play the role of centripetal force. Hope you understood this concept. Thank you. Let's meet in the next question or in the next video. Thank you.